Hi guys, today we're gonna explain the Learner's Book 1.3. And the topic is about the square roots and cube roots. Okay, so let's try to understand what the hell those things mean. Okay, for example, we know that we have an operation for the squares, right? If I say that 4 times 4 is equal to 16, I can also write it as 4 squared is equal to 16. Why? Why squared? Because I have 1, 2 fours. So that's why I say 4 squared. So when you say 4 squared, it just means 4 times 4. If I would say 4 cube, it means, so there are 3 fours, right? Because it's cube. I wrote 3. So it means that 3 fours, 4, 4, 4. It's not 444, it's multiplication. The same thing about 5 to the power of 4. So it means that I have fives. How many fives? 4 fives. 5, 5, 5, 5, and I'm multiplying them, okay? So that's it. You already know about this, right? So this is powers. But also, we have the opposite reverse operation of the same thing, okay? So if look at the relationship in between the 4 squared and 16, right? I say 4 squared is equal to 16. Similarly, I can give that relationship between 4 and 16 in a different way. I can write that 16 root is equal to 4. Just means that 4 squared is equal to 16. Okay, 16 root is equal to 4. Nothing weird. So now remember, 4 cube is equal to 4 times 4 times 4, which is 64, right? With the same type of equation, we write that 64 root, but which root? It's cube, right? So we say third root is equal to 4. Um, for fun, I can tell you that 5 to the power of 4 is equal to 625. Then 625 root, but which root? 5 to the power of 4, right? Fourth root is equal to 5. Okay, this is it actually. There's nothing else about this type of numbers. Okay, if I would give you some kind of equation in this type of numbers, if I say that x squared is equal to 9, then you know that x is equal to 9 root, right? From there, you can write that x is equal to 3. But do not forget that if x squared is equal to 9, and we said that x equals to 3 works, right? Then we also know that x equals to negative 3 works as well, because why? We said that x squared is equal to 9, right? So 3 squared is equal to 9. It's very good. But at the same time, negative 3 squared also is equal to 9, right? Because negative 3 times negative 3, negative times negative from the, so what is the negative 3 squared? We know that negative 3 squared is the same thing as negative 3 times negative 3. So we know that negative times negative is positive. 3 times 3 is 9. So our answer is still positive 9. So notice when we have something like this, x squared is equal to 9, x has two different results. Similarly, x squared is equal to 25. It means that x equals to 5, but also x equals to negative 5. Now we also have to notice something else. X squared equals to 5, then x equals to negative 5 as well, does not mean that square root of 25 is also negative 5. No, this is wrong. Square root of 5 is only, sorry, square root of 25 is only equals to 5. There is nothing else. Why? Because this is the way of this operation, okay? We always say that the number gets out of the square root is always and always positive. This is a rule, okay? Nothing weird about it. But let me mention something else. What is the square root of negative 25? What is it? Okay? This is a very important question. The answer is it does not exist. Okay? We can write it as D in E. Does not exist. Why we can say it? Because square root of 25 is some number, right? Square root of, sorry, negative 25. Square root of negative 25 is some number. Some number. such that its square is negative 25. And you can think a little and you can figure out that there is no such number. You cannot find a number where its square is negative. Because if there is no number, there is no such number. Why? Because if the number is positive, then its square is positive, right? Square is positive. So now look at this. If the number is negative, if number is negative, then square is the number times itself, right? Square is that number, so that negative number times itself. We know from the previous video that negative times negative is also positive. So no matter the number is positive or negative, its square is always positive. Then if the square of all numbers is positive, then we cannot have this negative number in square root, because square root says that what is the number that its square is negative 25. There is no such number. So important rule is that uh, square root of negative numbers does not exist. But we can little bit expand this rule, and we can say that actually even roots of negative numbers does not exist. What does it mean? It means that it doesn't matter if it's a square root. Also, the fourth root, fifth root, sorry, not fifth root, even roots. Fourth root, sixth root, eighth root, 10th root, as long as the number is even, doesn't exist. But now let's look at the cube root of some negative number, right? Let's say the cube root of negative 125, okay? So it looks for the number where its cube is 125. There is such number. The number is negative 5. Why? Because if you get negative 5 times itself 3 times, you will get what? Negative 5 times negative 5 is 25. 25 times negative 5 is positive times negative, so which is negative. 25 times 5 is 125. So you see, we got the exact same answer. So that means cube root of negative 25, 125 exists, but square root of uh, negative anything does not exist. So for cube roots, we don't have a problem. For even roots, we do have a problem. Odd roots, no problem. Even roots, we have a problem. So even roots of negative numbers does not exist. Odd roots means the third root, fifth root, seventh root, ninth root, right? Odd roots are okay. Okay? Now, let's try to solve some questions. Let's say 3a. 3a says that x squared is equal to 100. Then x is equal to square root of 100. Then x is equal to 10. Let's do part E. This was part A. So 3e. 3e says that x squared plus 9 is equal to 0. X squared is equal to negative 9. X squared is equal to square root of negative 9. We know that, sorry, not squared. X is equal to square root of negative 9. If x is equal to square root of negative 9, we know that square root of negative numbers does not exist. Okay? Let's do some about the question number 4. Well, let's say the first one. Sorry for a second. Actually, not sorry. That's okay. Question number 4. Let's do 4D. 4D. It says x cubed plus 125 is equal to 0. So x cubed is equal to 0 minus 125. Then x is equal to, if it was cube, then it's gonna be cube root of negative 125. And we already know that cube root of negative 125 is negative 5. Okay, so that was 4D. Let's do question 5 very fast. Question 5, we already know that 27 squared is the same thing as 9 cubed. Is it though? 3, yeah, it is. And that is equal to 729. We know that. And we have to use it to find, let's say, C. So we gotta use, actually D. We gotta use it to find this. Negative 729 root. Okay? Negative 729 root. We know that the root of normal 29, okay, root of normal 29, 729. So what's the number that its cube is 729? We see the number is 9 because 9 cube is 729, right? 9 cube is 729. But we need a number where its cube is negative 729. So the number would be negative 9. Done. And let's do question number 14. So 5 we also did. We did this one. Sorry. We did this one. And this one will be just 9. This one does not exist because it's a square root of negative number, so it does not exist. Okay, anyways, does not exist. D and E. So question number 14. This Venn diagram, this is a Venn diagram, shows a relationship between natural numbers and integers. Notice that the circle for natural numbers is inside of the circle of integers. That means every natural number is also integer, right? N stands for the, copy the Venn diagram. Okay, let's imagine we did. Write each of the numbers in the correct part of the diagram. So let's say 1. 1 is natural number. Negative 3. Negative 3 isn't natural, but it is integer, right? Because it's a whole number. 7. 7 is natural. Negative 12. It's not natural, but it's a whole number. 41. It's natural. Negative 100. It is not natural, but it is whole number. And 2, 1 over 2. So it's 2.5. It's neither natural nor integer because it's not a whole number, right? Because it is 2.5. So it is not a whole number. So it's neither in this circle or in a bigger circle. Oh, so it's in somewhere else. Okay? So it's in neither circle. That's it. We're not going to do the other parts of that question, okay? And yeah, that's pretty much it. Let's see in the next video.